You just pushed your API key to GitHub. It took a bot less than a minute to find it, and by the time you finish reading this sentence, someone could already be spinning up servers on your credit card. This is one of the most expensive mistakes a new developer can make, and almost everyone makes it exactly once. The good news is that avoiding it forever is genuinely simple once you understand one idea. So today you're going to learn how secrets actually work so that your once is never. Let's make sure this never happens to you. Here's what almost every beginner does, and honestly what most of us did too. You're wiring up a payment library, or a database, or some AI model, and the setup asks you for a key. So you paste that key straight into your code, right there in the file as plain text. And it works. The app runs. You feel like a genius. Then you commit your project and push it up to GitHub to save it or to share it with a friend. And that key, your private password to a paid service, is now sitting in public, readable by anyone on the planet who wanders past your repository. Notice that the code was perfect. The code was never the problem. The problem is where the secret lived. It lived inside the one thing you just handed to the entire world. And once a secret is out there in the open, you cannot quietly take it back. It has already been copied, cached, and archived in a dozen places you'll never see. So here is the one rule that fixes all of this, and it is short enough to tattoo on your arm. Secrets never go in your source code. Not once, not just for a quick test, not even for 5 minutes while you check that something runs. Instead, your key lives outside the code entirely, in the environment your program runs in, and your program reads it at the moment it starts up. The code says, "Go fetch the key I need." The code does not contain the key. That single shift, pulling the secret out of the file and into the surrounding environment, is the entire idea of this video. Everything else you'll see is just the clean, boring, reliable way to pull that off. Let's back up to what an environment variable even is, because the name sounds far scarier than the thing. Every program runs inside an environment, which is really just a little set of named values that the operating system hands to your program the instant it launches. Picture it as a backpack your app carries around. Before the program starts, you can tuck values into that backpack. A database address, a secret key, a setting that says which mode to run in. Then, inside your code, you simply reach into the backpack and grab the one you want by name. The value stays available the whole time your program runs, but it is never written into the code itself. Same program, different backpack, and you get completely different behavior without touching a single line. That separation, your code in one place and your secrets in another, is exactly what the whole industry has quietly standardized on, and it's why this pattern shows up in basically every serious project you'll ever open. Now watch the wrong way first, because seeing the mistake is what makes the fix obvious. Here it is spelled right out. You create the payment client and you type the secret key directly into the line, in quotes, as a plain string hard-coded in place. It's convenient. It's also radioactive. The instant this line gets committed, that key is baked permanently into your project's history. On screen, this is the line you must never, ever write. A real, live secret, hard-coded, sitting in a file that is about to travel up to a server you do not control, in front of an audience you cannot see. Almost every leaked key horror story you will ever hear starts with one single line that looks exactly like this one. It runs perfectly, it passes every test you throw at it, and it betrays you the instant it goes public. Here is the same code done right, and the difference is beautifully small. Instead of the raw key, you reference a name that gets pulled from the environment. Your program asks the environment for the value called, say, the secret key, and it drops whatever comes back into the client. The code now holds a label, not a secret. Anyone reading your source sees only the name of the key you need, and never the key itself. And because the real value is injected at runtime, you can run the exact same code on your laptop and on a production server, each one quietly pulling its own key from its own environment. Nothing sensitive is ever written down in the file that everybody can see. Your laptop reads a test key, the server reads the real production one, and neither actual value ever lives inside the repository. One tiny change to how you read the key, and the entire danger just evaporates. But where do those values actually come from while you're building on your own machine? This is where a small local file steps in. On screen, it's the one named .env. It's just a plain text file that sits in your project, and each line is simply a name and a value. Your local keys, your local settings, one clean pair per line. A tiny, extremely popular library reads that file the moment your app starts, and loads every line straight into the environment for you, automatically. So during development, you get all your secrets handed to your program cleanly, without a single one of them ever appearing inside your actual code. It's the convenience of hard coding, with absolutely none of the danger that comes with it. You edit that one file once, you never think about it again, and your keys just quietly show up wherever your code reaches for them. And this next step is the one that genuinely saves you, so please do not skip it. The very moment you create that local secrets file, you add its name to another special file. On screen, it's the one called .gitignore. That file is nothing more than a list of things Git should pretend do not exist. Files it will never track, never stage, never commit, and never push anywhere. You put your secrets file on that list, and from that point forward it stays on your machine, permanently invisible to your version history. This is the guardrail, the whole safety net in one line. Write that ignore rule before you write almost anything else, and the entire leak scenario simply cannot begin. It is a tiny, one-time habit that quietly protects you for the whole life of the project, and it costs you exactly one line. There is a second reason this whole pattern matters, and this one has nothing to do with security at all. A lot of settings need to change depending on where your code happens to be running. On your laptop, your app should talk to a small throwaway test database. In production, serving real paying users, it absolutely must talk to the real one. Same exact code, completely different values underneath. Environment variables handle this perfectly. Your development environment hands your app the test settings. Your production environment hands that very same app the live ones. You never crack open the code to flip anything. You just change what's sitting in the backpack. Configuration that varies from place to place belongs in the environment, living right next to your secrets for the exact same reason. Things like which region to run in, how much detail to log, or which features are switched on, all of it can flow in cleanly from the outside without ever editing the code that reads it. Let me show you why none of this is paranoia. Every single day, security researchers who scan public code discover tens of thousands of fresh secrets, accidentally leaked into repositories that anyone on Earth can read. Not tens of thousands per year, per day. Live database passwords, cloud keys, payment tokens, all committed by developers who were simply moving fast and forgot about one little file. This is one of the most common security failures on the entire internet, and it is happening right now constantly at a scale that is honestly hard to even picture. Every one of those keys is a door somebody accidentally left standing wide open, waiting for the first person to walk through it. And most of the developers who did it had absolutely no idea, right up until the damage was already done. Because the moment your key lands in a public repository, a clock starts ticking, and that clock is brutally short. Automated bots endlessly crawl brand new public commits, specifically hunting for anything shaped like a credential. We are talking seconds here, not hours, not days. GitHub itself runs a system, shown here on screen, that scans for known key patterns and can even warn the provider for you automatically, sometimes before you've even noticed. That's a genuinely great safety net to have, but you must never count on being rescued by it. Plenty of stolen keys get quietly used to mine cryptocurrency or to run up staggering bills, long before any human being notices that something has gone wrong. By the time you spot a strange charge on your account, that key has usually been passed around and abused for a while. And deleting the file does not undo it. This is the part that blindsides almost everyone the very first time. Git keeps history permanently on purpose, because that is literally its job. So even if you remove the key in your very next commit, the old version is still sitting back there in the timeline, perfectly readable to anyone who simply scrolls back far enough. The secret is not gone. It's just one click deeper than it was before. So once a key has been exposed, you treat it as burned, full stop, no exceptions. And there is exactly one correct response. You go to the service, you revoke that old key, and you generate a fresh one. That move is called rotating the key. The leaked one instantly becomes worthless to anyone who grabbed it, and your shiny new one never once touched a public file. Rotate first and clean up the history later. Scrubbing an old secret out of Git history is possible, but it is genuinely messy. It rewrites the whole timeline, and it never comes with any promise that nobody already copied the key. For real production systems, teams take this one step further again. A plain local secrets file is perfectly fine sitting on your own laptop. But for a live application serving thousands of users, you want something considerably stronger and more accountable. So companies reach for dedicated secret managers, which are services built to do exactly one job. Store your keys, hand them out securely at runtime, and track precisely who accessed what and when. Tools like AWS Secrets Manager, HashiCorp Vault, and Doppler all do this. Your running app requests the secret it needs, receives it directly in memory, and the key is never written to disk, never sitting in the code, and never parked in a loose file somewhere. It is the same core idea you already understand, just hardened all the way up for scale and for teams. Some of these platforms will even rotate the keys for you on a schedule, so that a forgotten or leaked one quietly expires on its own. A few small habits will keep you permanently out of trouble. First, never log a secret. Printing a key to your console feels totally harmless, right up until those logs get saved, forwarded, and shared, and now the thing is leaked all over again through a backdoor you forgot existed. Second, give every key the least power it actually needs, so that a stolen one can only ever do limited damage. Third, rotate your keys on a regular schedule, and immediately the moment anyone leaves the team. And fourth, never ever commit that secrets file. Glance at your ignore list before your very first commit, every single time, no matter how small the change feels. Nearly every disaster in this space traces straight back to one rushed, careless push. Slow down for 2 seconds, and you dodge every last one of them. So let's pull the whole thing together into 3 clean lines. 1. Secrets and anything that changes between environments never live inside your code. They live in environment variables, loaded fresh at runtime. 2. On your own machine you keep them in a local secrets file, and you make absolutely certain that file is ignored by Git, so it can never ever sneak into a commit. And 3. If a key ever does leak, remember that it's in the history forever, so you rotate it immediately, and for production you graduate to a proper secret manager. Keep the value out of your code, and you close the door before anyone can even reach for the handle. If this just saved you from a genuinely terrible afternoon, do the one thing that helps this channel the most and subscribe. Next in the series, we go deep on the tool that quietly started this whole mess and also happens to rescue you from it. Git itself and how its history really works under the hood. Now go double check that your keys are actually safe right now, and I'll see you in the next one.